Okay, good morning. I can sort of tell by the fact it's gone quiet that you can hear me, so we will assume you can. So good morning and welcome to the Sorce conference. This is the second time we have held an event like this, and it's good to see so many of you here. Of course, when you plan an event, you're never quite sure how many people will actually turn up. So thank you for turning up. So I've got someone to actually speak to. Okay. So what we are, for those of us who don't know, we're the Science and Engineering Research for Cultural Heritage Network here at Imperial. So what we try and do is link the scientists and engineers here at Imperial with questions in cultural heritage. And I started this network a few years back because I could see I was working on cultural heritage problems, some of my colleagues were too, but actually everyone thought they were the only person to do that at Imperial because we are science and engineering. We don't have a sort of arts side to the university. So that was where the idea came from, and there is more information up on the website, which has got some open access versions of Imperial College publications, because we tend to publish in the science and engineering literature, and I know not everybody has access to those publications. Hence, where we've been able to, we put open access versions of them, of those publications, up there for you to get hold of. And also some of the examples of sort of work we have done in this area, because we've worked on many different materials and many different areas and many different research questions. So there you go. There is an example of the website. So feel free to go and have a look what is there. And as I said, it's got that, the network has that idea to link scientists and engineers with cultural heritage, and part of this comes out of where we are. We are here on Exhibition Road. We are part of Albertopolis. So after the Great Exhibition, the area of science, culture, learning that was set up. And those sort of institutions have got a little bit far apart, perhaps. We often say that Exhibition Road is very wide. It's very hard for people to cross from Imperial to the Victoria and Albert Museum, for example. So one of the things we're trying to do is encourage people to do that, and encourage collaborations within this small district, but also much wider collaborations as well. So what sort of collaborations do currently occur? Well, there are research projects that will fund postdocs and PhDs, for example, from the funding councils, and I know between ourselves and some of you, we do have funding bids in at the moment that we are awaiting responses from. What we also get is we get applications from people who want to do PhDs and have their own funding, either from their government or themselves. So there's often self-funded students who want to do a project, and it's nice to do that project in collaboration with people like yourselves. Similarly, of course, we have lots of undergraduate and master students going through. Each of those does a research project at the end of their course, and once again, that is how we often collaborate with museums, etc. And of course, we do short projects as well. People have a question, need access to a scientific technique. Can we have a look at this sample and see what it is, for example? We do that as well. So if you've got any questions like that, I've sort of put myself forward as a point of contact. I've got a reasonable idea who does what at Imperial, or I've got a reasonable idea who to ask to find out who does what. So if you've got questions, by all means, talk to me, email me, and we'll see if we can put you in touch with a useful person here at Imperial. So that is who I am. So as I say, feel free to contact me. And at this point, I will say welcome again, and I'll pass you over to Fabian, who is chairing the first session. Thank you.
Thank you very much. Thank you, Ambrose, for that introduction. So as Ambrose said, I'm Fabian. I'm a teaching fellow in the Department of Mechanical Engineering, and I'm going to be chairing the first session. So I'm very excited to introduce our first invited speaker. So that's Alex Marsh, Director of Operations at Park Royal Open Workshops and Remade in Park Royal. And today he's going to be talking to us a talk titled Building an Innovation District from the Bottom Up. And the talk will explore how grassroots initiatives can foster vibrant and sustainable creative communities. And please join me in welcoming Alex.
Thank you very much. Hopefully people can hear me. I have to admit, I slightly said yes to joining you guys here today without fully looking at the sort of title of the conference. So I think this is going to be something slightly different from the other speakers possibly, but I think I've been reassured that that's a good thing. So we'll see by the end. But hi everyone. So yes, as just been said, I'm Alex Marsh. I'm one of the directors at Park Royal Open Workshops and Remade. We're an open access workshop, as the name suggests, in Park Royal. For those of you who may not know what an open access workshop looks like, we describe ourselves as like a gym, but instead of weights and treadmills, our shared equipment is power tools, large machinery for metalworking, woodworking, all of those kinds of things. And we are one of a number of spaces that exist in London that look a little bit like that. Building Blocks up in Enfield probably being the largest one, Black Horse Workshop, there's a few others. And of course actually here in Imperial as well, Imperial Hackspace and others. But I think what will be interesting about the talk today is not only just giving you guys a taste of what that actually looks like and how organizations like POW and others can play a role in sort of fostering sort of, as we call it slightly grandly, a sort of bottom-up innovation district, how we support the development of arts and culture more generally, but also actually how it interfaces with larger institutions of the likes like Imperial and others, how innovation comes both from sort of the top down, from the large institutions, but also from the bottom up. So just to give a few opening stats, crafts businesses in the UK currently employ about 150,000 people, contributing about 3.4 billion to the UK economy every year. And London is obviously a key part of the creative industries, of which the craft industries are obviously a key part. Sort of around 62 billion in GVA and 50% of the sector's contribution coming from London. So this enormous success story that is the creative industries in London. Driven in large parts by things like the film industry and other things like that. But again, crafts play an important role in that. And actually, what we see from the ground is the way that actually the interdependencies of a large Netflix production, how that's actually underpinned by hundreds of individual small businesses, freelancers and others, who permeate into the worlds of crafts, sort of, heritage, the sort of fine arts, all of these different sectors, the very large stuff in the UK wouldn't exist without this huge network of smaller things that underpin it. So those are that's the sort of the good news story. And then the not so good news story, 1 in 3 artists and makers give up during the process of sort of setting up their practice. And that's driven in large part by just the cost of setting up a studio and running your practice in London, but also just the financial precarity of that industry is fairly, which is, well, it's going to be clear to all of you, I'm sure. And that financial precarity then also leads to a sort of a huge imbalance in terms of the makeup of that profession in particular. So less than 20% of design engineers come from a lower socioeconomic background. Only 1.2% of revenue-generating artists are female, and only 7% of the workforce in the creative industries are from an ethnic minority background. And that's particularly shocking when you think about the fact that the vast majority of the creative industries are based in London, the southeast, where the demographics are considerably more diverse. So there is this kind of huge imbalance that exists. And that's then underpinned in London as well by huge property pressures as well. So 24% of current sites used for arts and crafts productions are at risk of closure within the next 5 years. And I should say that, so my background is actually, I come from a sort of public policy background. I worked in the Mayor of London's office for more than 8 years, working on funding and creating and securing artist workspace and creative workspace more generally. And this was a very live issue that we dealt with over that time. And the Mayor of London, previous mayor and current mayor have actually there's a degree of continuity there in terms of actually prioritising the sort of safeguarding of these kinds of spaces. But the pressure is still there, it's very real. And then the other part, the key part as well, that the worlds of creative production is still very much one that is dependent on who you know. So 67% of artists indicate that they hear about work and financial opportunities through their networks. So there's essentially still a need to find your work through the connections that you make, which means it sort of, again, is one of those things that gets in the way of greater diversity within the sector more generally. So and that's a big part of then why we set up POW. As we describe it, a new space for makers, to precisely combat and tackle some of those issues. Across the 4 directors, we all come from a sort of diversity of backgrounds. Some fine furniture making, myself being a sort of a hobbyist turned professional, I guess now. Model makers, but all of us know the pressure within London, which essentially is one of space and cost. It is very difficult to make a living from these industries in London, precisely because primarily property is so expensive. And if you're dealing with large-scale making, as if you want to make a living, equipment is big, it takes up space. You're not only paying for the cost of the equipment, but you're also paying for the square footage that you're renting to actually just house that equipment. And it very quickly becomes pretty uneconomical unless you have a very, very well-defined business model. And so that's really the mission that we set up to sort of tackle, to essentially take on some of the, let's say, the logistics of running a space like this. So making sure that people have access to high quality equipment, the right kind of space to make, and giving them the time to essentially focus on the making side of things, the bit that they are really good at. So that was the sort of the objective that we set out with. We have 3 strands to what we do. So what we call make, learn, and made. So starting with the simple one, make, we have 7,200 square feet of making facilities, so wood workshops, a classroom, a spray and drying room, and a digital suite as well, which includes things like laser cutters and CNCs, 3D printing as well now. And all of that is made available at very, very flexible, on a very flexible basis. So people can come in and literally rent a bench by the half day. So you can really come and use the facilities and pay for the facilities for the time that you use. In my view, there's nothing more annoying than, if going back to the gym analogy, joining a gym, getting the bill at the end of the month and realizing you've actually only been once and you're still paying £300 to be a member of that gym. So for us, it was always about saying, right, it should be fair and people will pay for the time that they use. And that's by sort of dividing up that time, we can essentially make it as affordable as we can possibly make it. Things like even the spray room, we actually rent out by the hour. It's the sort of, I guess, crudely, it's the co-working model for the industrial sector, which for various reasons hasn't really, to date, really taken off, but is going to be key to actually, in a city like London, where property is so ferociously expensive, those kinds of models are desperately needed. Learn, so we do full sets of training, we do teaching, making sure that firstly everyone who comes into our space knows how to use the machine safely. That's obviously a very, very key part of what we do. But actually that's now branched out into a much broader range of teaching and upskilling as well that goes alongside that. So that includes sort of more specialist courses that we start to run with real specialists in crafts and other sectors as well as more introductory courses for hobbyists. We recently ran an introduction to welding course for the Park Royal Women's Group as well, so a whole range of sort of more specialist training and other sessions that we run as well as part of this. And then, whoops, formatting went a bit wrong on that one, but Made, which is a big part of what we do now, and that's a commissions-based model. I think when we opened our door, first and foremost, we got approached by so many people saying, I don't want to make it, but can you make it for us? And we initially said, no, that's not what we do. We don't do that. And by the 10th time you've been asked, you sort of go, well, maybe there's something in this and it's worth pursuing. And so, but again, we were very clear. We know we don't want to become another joinery. We don't want to become another metalworking shop that simply takes on sort of large-scale commissions. So the ethos that we take on is that we all come from a background where we're used to dealing with sort of large contracts, dealing with the complexities of working with clients. We would take that side of things on. But actually, the work that we get through, and just to give you an idea, we've now done a complete office furniture fit out for our local development corporation. We've done 3 Ealing libraries. We've just now completed a large architectural model carved out of a 600 by 600 by 600 square bit of sequoia that will be hopefully shown in the Royal Academy. So a real wide range of things. But the idea is that we as the workshop don't take on that work. We bring in our network of users, residents as we call them, people that have more permanent access to the workshop, and other local businesses. So it's a real sort of local economy story. So rather than simply us squirreling that work within the confines of our 4 walls and taking on that work, we're essentially trying to work collaboratively with a wider range of other partners to sort of spread the love and some of the financial benefits that come from that as well. And then Remade in Park Royal, which is has been a sort of project that we've taken on. This was actually an earlier iteration of the project, but I just like the image. So we obviously work around a lot of industries that generate a lot of waste. And the film industry is probably the prime example of that. I was on a call recently where I was sitting alongside a material buyer for the film industry, and we were working with HS2, looking at all of the timber that they generated during their sort of the build of the big new station that's arriving around the corner. And this buyer for the film industry turned around to me and said, I've just bought more timber than HS2, and that was for 1 film shoot. So just to give you a sense of the scale of waste that's within sort of industries that aren't typically sort of seen as large waste-generating industries per se. But the idea of the Remade project is essentially to act as a broker between those industries that generate waste and the makers and small business that would actually benefit from having access to affordable materials. And I mean, we've been properly up and running since sort of January last year for a year. We're now at the point of having shifted in really 1 corner of our workshop, essentially about 8.5 tons of material. We keep very close track of all of that. That's around 12 tons of embodied carbon that we save from that. And as you can see, it's not actually that many businesses that provide it. So the businesses that we work with are really providing stuff at scale. We do take smaller things, but really we work with larger businesses that provide a more regular flow of materials. And the vast majority of that has already found new homes, and that's in a whole range of smaller makers, smaller businesses, community organisations, community infrastructure that is built out of reclaimed material. So it's sort of a nice sort of circularity story that comes out of that. And just to give an example here, this is some of the studios that were built in just outside of our workshop, actually, sort of built from about 85% reclaimed materials from the film industry. We worked with a materials agency called Recollective, who designed these truss structures that were used to sort of hold up the structure, and that is all from leftover 11mm OSB that gets used very commonly in the film and construction industry. It is essentially, once it's taken down, usually just chucked on the skip. Here they've designed a sort of load-bearing truss structure that can actually use really, really small offcuts using some of our CNCs and other things like that. So yeah, sort of a nice turnaround, taking waste and embedding it into some of the kind of community structures. And then the exciting part for us is our workshop is really located in an area of quite substantial change that Imperial and others will also be hopefully part of in the near future. So we are based in Park Royal and Old Oak, which some of you may know is the terminus for the HS2 station. Sorry, not terminus now, the interchange for the HS2 station, because the Euston branch is going ahead, apparently. But for the moment, temporary terminus. So yeah, huge scale regeneration that's happening there, the largest project since the Olympics. And I should say, in another part of my past life, I was the head of development, or head of regeneration and economic development at the OPDC, so I've sort of been on the inside of this as well. But yeah, very large scale change that is coming down the tracks for a sort of part of London that hasn't really seen much change in the last sort of 30 years. Whoops, the formatting went very wrong on that one, but never mind. But key ones here, I think, we're talking 26,000 homes, new homes that are coming next to, very close to our workshop, 2.5 million square feet of new commercial space that's part of that, 2 million square feet of new industrial space within Park Royal as well. Huge changes. Imperial has obviously just bought the Victoria Industrial Estate just around the corner from us, and very, very significant investments in public realm and other infrastructure as well. All of that change is potentially a really, really good thing for the workshop and for the smaller businesses that we sort of exist around and with. We can obviously sort of, us being better connected to the rest of London and to the rest of the UK is absolutely a good thing, but there is this big potential downside that the risks that are coming and the risks that potentially impact those smaller businesses that rely on us and other premises in the area, the rents will inevitably go up. That is unfortunately the reality of large infrastructure investment in London. It comes with a subsequent rise in property price. It's partly why people do big infrastructure investments like HS2. And the risk would be that power would be priced out of the area, along with a lot of the small businesses that currently kind of give the area its vibrancy and interest. And so what's next? The exciting bit for us is, and this is so new that I actually don't have any images to share because they are literally being prepared today, but we have just secured around £250,000 in grant and loan funding from a variety of sources, and we will essentially be creating doubling our footprint by building in a new industrial mezzanine. In keeping with the sort of the remade project, actually we're using a reclaimed mezzanine that's being taken out of an old supermarket, and that will essentially be reformatted in our new workshop. And with that, then we'll be investing in a lot more additional sort of workshop machinery. So really professionalizing our woodworking offer, introducing a much expanded new metalworking offer, as well as then actually those kinds of equipment like water jet cutting, potentially fiber lasers and other things that are really well beyond the reach of most small businesses. But again, by us taking on some of the maintenance and costs that are associated with that, we can essentially make that available to those smaller businesses at affordable prices. I think that's sort of where I'll conclude for the moment, but just to say that sort of I think the way that we see the sort of the innovation side of things also really being key is the sort of the collaborations that we have in our local area. And we're very lucky that we're part of a network of hugely sort of interesting and engaged local local actors, all sort of smaller scale, but I think that, and some of them who would have been here today, unfortunately couldn't quite make it. And I think that's the other key part of how we sort of, when we think about embedding a sort of an innovation district, for want of a better term, it's never possible for us to do that within the confines of our four walls. It has to be through collaboration with others. We're very lucky to have an extremely collaborative landlord. So, for instance, we work very closely with the Development Corporation. We've got some exciting work in the pipeline with Imperial and other people who are sort of moving into the area. So yeah, it's always about that sort of looking outwards and collaborating with others. But I'll leave it there. Thank you very much.
Okay, thank you very much for that. It was really interesting to hear about what's going on at Park Royal and sort of the opportunities which are available for everyone, ourselves, and probably very useful to everyone in this room. And on that, do we have any questions for our speaker? And also, with questions, if you could just wait for a microphone to be passed to you because of the recordings. And then we've got one down here after as well. Thank you.
Hi there. I was just wondering how much appetite there is for fundraising or for fund achievement on this kind of work, because it's something that would be really interesting at the institution where I work, but it's quite an intimidating kind of prospect figuring out where do you even go to get started on funding these kind of projects.
Well, previously it would have been a really easy solution. I would have said, come to me when I was at the Mayor of London's office, because that was precisely what I was doing, and we funded more than 50 workspaces, actually, all across London, including Building Blocks, Black Horse Workshop, Makerversity. Most of the makerspaces that sort of were set up about 5 years probably had some regeneration funding that came via the Mayor of London. Unfortunately, that funding stream has dried up. And the reality is the days of where we signed off pretty large amounts of money to some of those workspace projects are unfortunately gone. And the funding environment is much, much more fragmented now. It's not to say there isn't stuff out there. We've had some luck because we're near the HS2 station, so we've sort of done quite a lot of work with HS2. Obviously, the OPDC has given us some funding in the past as well, but really much smaller amounts than was previously available. So that, unfortunately, it's a bit of a downer answer, but yeah, the funding environment is tricky at the moment, and yeah, we're definitely navigating that at the moment.
Okay, thank you. So,
firstly, amazing project and
Thank
well
you.
done. I've got two questions. Under the MAID, do you have a 3D printer?
Mm-hmm.
And so that might be something that museums could
Absolutely.
commission?
Yep.
Great. And then under the remade, what sort of materials do you accept?
Yeah, good question. So it's probably, so actually coming to the point about sort of broader collaboration. So for us, we run essentially a shop within our workshop. So we focus very much on the materials that get used in our workshop, which mostly comes down to timbers, sheet materials, some metals, some plastics for laser cutters and other things. But actually one of the really nice things that's come out of the remade project is we did a little bit of research with HS2 and OPDC looking at basically sort of seeding grassroots circular economy organizations. And off the back of that, actually, we managed to secure a temporary space just around the corner for basically circular economy organizations of a wide variety of types. So in there, actually, we've got Recollective. So they work specifically with the film industry to take sort of materials that are generated from film waste, essentially. There's an organization called Rescued Clay that take just clay spoil. So when you're digging out tunnels in London, you're doing infrastructure work, you're going to hit London clay. And the usual sort of business as usual is that gets shipped off in a big old truck that has, you know, terrible emissions. It gets shipped off to a disused quarry somewhere and dumped in there. And so Rescued Clay instead intercept that rather than it go traveling, you know, more than 100 miles probably in a truck. It instead travels 2 miles to their site, and they turn it back into ceramics clay. So a really, really interesting example. But the idea of that space, which is just being set up at the moment, is that there'll be a wide variety of organizations that are all dealing with different types of the sort of waste streams that sort of come in there. So I think, yeah, if you're interested, I'm more than happy to share details on that and as that sort of develops.
great, thank you. And we have time for one more question if there are any others from the audience.
My question is really to do with conservators. Do you have a sense of how much your facilities are being used by freelance conservators who are not, don't have their own access to some of the equipment that you're using? I've always associated these things with community projects, but I'm wondering how much the kind of professional services are using it.
It's a good question. Yeah, at the moment, not a huge number, but I think that's what we find is that it's a sort of network effect. So the minute you get one person using facilities in a certain sort of niche or subgenre of making almost, you suddenly find that you get sort of more and more of those. So we've suddenly had a whole load of instrument makers, and that's essentially off the back of one instrument maker who came to us, found us, and then spread the word in his part of the community. So I suspect, so at the moment we haven't had many conservatives, but I suspect, certain parts of the facilities which, are certain basic facilities that you need for making more generally would still be of interest. I suspect there are probably some more specialist tools and equipment that conservators would use that we probably don't provide at the moment. But I think that's part of the interesting part of the model, essentially, that I think actually there are almost endless variations of the types of facilities that we provide, whereby you can just specialize in providing for jewelry makers or conservators or, very special, or knife makers who need a specialist, sort of very particular type of metalworking facility, say, for instance. So I think there's definitely a potential there, even if it may be under-resourced at the moment.
Okay, well, thank you very much for all those interesting questions, and thank you again, Alex, for your really interesting talk, and I'm sure we're going to have some more questions in the breakthrough as well, so thank you once again.
Thank you.
Okay, so next we have a contributed talk, and this work is, as you can see from the title of the slides, by a number of people, but who I'd like to introduce today is Dr. Liva Donina, who's a visiting researcher at Imperial College London. I would also like to introduce Marcy Talbot, who is a final year MN student in design engineering as part of the Dyson School, but she's not going to be presenting as part of this, but her work has very much played a pivotal role in this talk, and also Dr. Elena Dieckmann, who's a lecturer in the Dyson School of Engineering. And their presentation is titled Marble ID, Artisanal Cryptography. And this is focusing on how marbling craft techniques can inspire novel approaches to cryptography. So sounds like it's going to be very interesting. So please join me in welcoming both our speakers, and the floor is yours.
Is our microphones working? Yeah, I think. Okay. Thank you very much. We are Elena and Liva, and Marcy is up there as well, so she's one of the driving forces actually behind the project as well. We originally met at a IMSI workshop, so thank you so much for IMSI to make this project happen in the first place. And today we would like to present the current progress on our project and also a future vision.
Yeah. So I guess, can you hear me all right? I'll just start by kind of giving a bit of background about me. So actually I did my PhD and a year of postdoc at Imperial. So my PhD work was on kind of using microfluidics to induce flow changes in kind of highly concentrated surfactant systems. And during my PhD, I really got into public engagement and did quite a lot of work with Imperial Lathes and Great Exhibition Road Festival. And I had funding for a year from Royal Society of Chemistry to kind of teach kids about surface tension and surfactants through the craft of marbling. So I'm personally really interested into craft, learning new crafts. So I kind of wanted to incorporate that into my research or PhD in some way. And really this idea of kind of bringing together marbling and engineering was born through outreach. And then following that, I worked as a postdoc for a year. I'm a visiting researcher now because the funding has run out. I don't know if anyone has been in a similar situation. So now we're just applying for funding with the Cross Research Council grant. Elena, would you like to? Sorry.
My name is Elena. I'm probably the most junior lecturer in the Dyson School of Design Engineering. My research area is mostly related to creating new design concepts, mostly for sustainable innovation. My work spans across new ways of recycling chicken feathers to photovoltaic panels, and also digital materials, so materials that sit at the intersection of the digital and the physical world. Okay, let's make a start. So I think this is a view that many of you guys know. I don't know, we take at least 12 flights on average as Europeans. I think maybe the number is higher in the UK. I'm wondering how you would feel if I tell you that 2% of the airplane you're traveling on is fake. Yeah, so 2% of all the parts are fake. It's a harrowing number, and it's staggering. So 2.5% of the world's trade volume is actually based on pirated goods. So that's 464 billion. And this amounts actually to the entire GDP of countries like Belgium and Austria. The risks of counterfeit goods are harrowing, and we can find counterfeits and pirated goods actually in all kinds of product categories. So we have up to 10% of all the medicine that we consume is fake. 2% of airplane parts, as I mentioned, which is probably the most dangerous sector where fake goods are found. 10% of all the electronics are fake. And the highest number is actually found online. 36% of all the digital information is fake as well, especially when it comes to images. And this number is rising due to the introduction of sophisticated AI systems. So there are risks that are psychological when we look at counterfeited or pirated pictures, for example, but they're also physical, right? So you can imagine if we consume tampered medicine, that there is a toxicological risk for us. In airplane parts, we have the risk of fire hazard, engine failure, and also when it comes to electronics, there's simple things like fire risks, for example. So overall, it's a problematic challenge here for us. In terms of consumer goods, we actually have the rise of the super fakes. And if you have visited some countries, you're actually taken to markets where you can buy the perfect Hermes handbag or the amazing Louis Vuitton wallet for a fraction of the money that it looks absolutely realistic. When we look at the goods, I hope you can read it. Actually, perfumery and cosmetics is the most prevalent sector. Then we have clothing, and a very worrying number is also toys. We actually expose our children to quite a significant number of counterfeit goods as well. The European Union has launched a very interesting report, so this is an extract from this, the ACAP guide, which is summarizing all kinds of different technologies that we are actually developing to help against counterfeiting. And they really range from digital marking systems to mechanical solutions. I think a lot of you might know. So that might range from RFID tags, which can actually be easily copied, to NFC, chips, magnetic stripes. We have also something like DNA coding. For example, in the food industry, you can sprinkle DNA traces to understand where there are fake goods being produced. So there's an emerging of a lot of different technologies right now, and we are just figuring out what the best application for all of those products are that we are consuming and buying. One of the more interesting areas, which is really keeping researchers awake at night, is PUFs, so physical unclonable functions. So this is an emerging research field that we actually engaged with through this project, and Liva is going to explain what PUFs are.
Yeah, so physically unclonable functions are objects or systems that can take different inputs and return sort of, different outputs. So you kind of have a unique input and it returns a unique output. And they're usually generated through some kind of stochastic manufacturing methods. And by that, it means that we can use physical systems that actually have a lot of kind of randomness and stochasticity to generate these. And they're kind of usually easy to produce, but they're very sort of difficult to replicate, or impossible to replicate. So when we kind of think about physically unclonable functions, there are kind of different types, but really for this project, what we were kind of focusing on is optical physically unclonable functions. So we have, for example, kind of the first optical PUF that was described in literature, took laser so there was some sort of structure. It took laser input at a specific angle and would produce a scattering pattern. And by changing that angle of the laser, they were able to produce different kind of speckle patterns. So, for example, in this literature study here, they use silk, so natural material, to kind of receive different inputs and produce different outputs. And our idea was kind of, why don't we use marbling craft, which is, I'll kind of tell you a bit later more about marbling, which actually fell out of vogue because it was very highly irreproducible, and because it relies on a lot of these kind of natural processes, stochastic processes, to generate unique patterns that we could use for kind of anti-counterfeit applications. So a bit about marbling. It's a paper decorating technique that I guess kind of the original, the kind of essence of marbling is floating ink on water. The kind of first example of floating ink on water originated in 10th century Japan, where it was called suminagashi, or floating ink. And kind of separately, a couple centuries later, different sort of floating ink on paper technique emerged in Iran and Turkey, where it was known as Ebru. And this is maybe, if you have seen marble patterns, maybe in antique books, this is what you would have encountered. So the difference between these two techniques is that in Ebru, you use not just water, you use water that has been thickened with something, usually carrageenan or seaweed, essentially. And then kind of through ancient trade routes, marbling traveled to Europe, and finally in 18th century, it traveled to the UK, where it was widely used in books, in kind of decorating covers and insides of books. If you maybe ever visit a V&A or a natural history museum, you will see that lots of kind of 18th and 19th century journals would have marble patterns in them. And I also, in the UK, because they were sort of trying to, it was a sort of a larger scale production, lots of kind of information emerged about how to do marbling reproducibly, how to create certain patterns. So this was quite a sort of book published by Charles Woolnough, really tried to sort of formalize these different techniques to kind of, I guess, have that reproducibility. But I guess with the beginning of industrialization, it sort of, and cheaper techniques sort of emerging, marbling fell out of vogue, and then it was mostly a sort of, it was mostly a hobbyist thing. And it had a bit of, I guess, a revival in 20th century in United States, where I guess a lot of marblers, especially in kind of Massachusetts area, still are. And there was this lovely book published by, I forgot her name, sorry. But it was a lovely book published by someone at the Met Museum that kind of did a sort of massive review of all these people that are still alive that were, into marbling. And one interesting thing that I kind of wanted to mention, thinking about counterfeiting, is that marbling actually was used as a anti-counterfeit method for banknotes in like 16th, 17th century, both in the UK and also in the United States. So it's quite a kind of interesting historical link for this technique. So yeah, kind of more about marbling. So in marbling, you can really generate a wealth of patterns depending on, I guess, the physical conditions that you're using. So here I have sort of summarized just a few. So maybe on the top left, you have a sort of a peacock pattern. Again, you can see this is sort of, I guess, more regular, more reproducible, and then you have these more, I guess, random patterns at the bottom. This one on the bottom left is, if I'm not mistaken, a Stormont pattern, where you kind of mix paints with a bit of oils or like a bit of turpentine, and it generates this kind of speckle pattern, and the kind of tiger eye pattern on the bottom right, which is kind of still a bit of a guarded secret in the marbling world of how to create this pattern. So as I mentioned, marbling relies on floating ink on water. So you have marbling water. This can be thickened in a kind of marbling that we kind of think of, not suminagashi. This is usually thickened with lambda carrageenan or Irish moss. The Then you have the inks, and the way you sort of adjust how the inks spread is done by adding a surfactant. Historically, this was ox gall, which is from basically bile acid of a cow. These days, you don't need to use that. You can just use different surfactants, commercially available surfactants. When I've done these workshops, we just use very liquid. So you add a surfactant, and what it will do, it will sort of adjust how the ink spreads through something called a Marangoni effect. So as you're adding surfactant to the ink, it decreases the surface tension of this ink, and the greater the surface tension difference, the more the ink is going to spread. There's other things at play. So obviously, once you have added your paints to the water, you will manipulate that pattern, and depending on how you manipulate that pattern with a tool, at sort of what velocity you're moving the tool, thinking about other things you can add, as sort of in these examples I showed, like other additives you add to the paint, you really can have a sort of a wealth of different patterns that emerge. Elena, would you like to kind of introduce the?
Yep. So this is our overall research vision, how we are aiming to take this project forward. So actually, during the course of this project, we reached out to the marbling community and talked to them about this idea. So most of them were very excited about it. So it's our attempt to catapult this amazing ancient craft into the digital world, really. So our idea is to work with artisans and marblers all around the world to collect their unique signature and how they make their patterns, and then evaluate it for the cryptographic potential. So then create a database for pattern storage and analyze this. So Marcy especially has done a lot of work on this. She has developed a script how to process the images, how to recognize certain features, and Liva will talk about this in a moment as well. At the same time, there's a lot of different experimental conditions that actually impact the randomness. So there's a lot of different factors, from viscosity, velocity of the tool that you're moving, of the types of tools you're using, the surface tension, and the material chemistry that actually all contributes to the unique pattern formation. And in the world of marbling, it seems to be almost like a secret and a certain signature that the marblers are using, that they're keeping almost their own fingerprint almost to their own practice, which is really interesting. We also try to recreate the simplest marbling sumonagashi in the lab. So we created an automated platform where we dispense different droplets at different speeds and volumes, and then try to characterize and analyze the patterns that are coming up. And it's actually absolutely uncontrollable. So this was one of the interesting things. Even though we really did a lot of repeats, it stays chaotic and absolutely random. Going forward, our idea would then be to develop also an application platform that goes with an app, how you can apply this pattern then on large films, for example, to tag big objects that could be a part of an airplane, a part of a medical equipment. But we also discussed with Tanya Shtataki from electrical engineering, who was quite excited about the idea of using this for tagging and watermarking images potentially. So there's also a digital component where this might be used. This is overall our research vision, and Liva is going to introduce a little bit the pattern recognition part.
I think there was a slide. No, there was no slide before. So as Elena mentioned, with the help of Marcy, we developed this automated platform. I mean, very simple idea. We have some kind of liquid dispensing and then moving arm for which we control the velocity and hopefully, try to reduce the amount of kind of variability that we have in creating these patterns. So there were a few things we wanted to look at. Initially, it's kind of feature matching, how well we sort of can recognize this pattern with some kind of digital tool. Then check the robustness of real versus kind of fake marble patterns. So marbling is very difficult to recreate with marbling. But if you think about, taking a photo of it and printing it, that would kind of defeat the purpose of it. And then kind of think about the feasibility to use marbling as a physically unclonable function. So this is kind of, I guess, quite early days of this work. So this is work done by Marcy. So what we wanted to see is how well we can sort of digitally feature match different marbling patterns. So Marcy was able to kind of test an algorithm that was able to feature match the different marbling patterns really successfully. One problem, obviously, that we encountered was that if you just take a photo of a marble pattern, that is also going to be feature matched. So then kind of what we wanted to think about next is how can we recognize real versus fake? So what are the differences in sort of if we have a real marble pattern versus something that's been printed? And there we kind of wanted to think about like how the marbling is going to differ on like a smaller length scale. So if you zoom in, what are the sort of differences going to be? So we have just two images here. So we have, no, that's a good question. Which one is the which one is the real one? Which one is the fake one? But when you zoom in, if you print out with a digital printer, the way a printer will work is kind of by, I guess, dots per inch. So as you're kind of zooming in, the differences you will be able to see is that if you do a Fourier transform of the different images when they're zoomed in, you will be able to see kind of the kind of regularities of the sort of pattern that a digital printer would have.
I think the first one that you see, Marcy, can you? I think the first one was the real one. Yeah, and the second one is the copy one. Yeah.
So there's, kind of way at a certain length scale to tell the difference. But again, the questions are obviously, how good is the printer, and how feasible then it is to sort of feature match. So there's, I guess, questions remaining for this. And then finally, this is kind of just more thinking process, like what, in a sort of physically unclonable function, you have different inputs and you receive different outputs, but how in this context of marbling, how we could have these sort of like almost you have a laser, you have infinite amount of angles you can apply to the object, and it will give you infinite amount of scattering patterns. But in sort of marbling context, how would that look like? Whether we're zooming in into the pattern at different length scales and seeing these sort of observing these differences between kind of larger scale and smaller scale structure, or is it something that Marcy kind of was thinking maybe it's a physical one-way function? So, how can we sort of think about this as having these different challenge response pairs? And that's kind of this is the team that I guess we assembled to kind of, so this work has been put for a bid for the Cross Research Council grant. There's many stages of it, so I think we should be hearing sometime in April if we get to the full stage application. So there's still kind of, I guess, a lot of work to do. And this is the team. So we're working together with researchers from Institute for Sustainable Heritage, kind of who are helping us on the Arts Council side of things, and researchers from Imperial, and also we have different collaborators in Heritage Crafts, Natural History Museum, V&A, and the Met Museum. Yeah, and thank you very much for listening.
Thank you both very much for that. Some really interesting stuff to see, and maybe some worrying stuff as well at the same time, especially sort of counterfeit medicine. I didn't realize how prevalent it was. We have time for one very quick question. We've got one there, and then I encourage any other questions we can discuss in coffee and tea breaks and lunch breaks.
Well, thank you. I was just curious, at the beginning there is the craftsman element for the marbling. I was wondering if, for the final workflow, if craftsmen would be able to be reintroduced into the workflow.
Absolutely, yeah.
So I guess our kind of idea or hope is that really is the physicality of the craft is essential for that randomness. So I guess the craft itself is essential to it. So we cannot kind of go and, I guess, generate this with, I don't know, like with DALL-E or something. So it's really like the person, the craft is essential.
Yeah.
And I guess maybe in terms of the workflow, we're hoping to, I guess, work with the crafts people to kind of better understand the technique and maybe understand, how the artisan's hand is generating the randomness or the uniqueness of the pattern.
Yeah. Very practically, it could even look like that you have licensing models, right? Where artisans are creating those patterns worldwide that are very unique, and then they could be applied to different objects, and they actually get refunded for this. Yeah.
Great. Thank you very much, and thank you again for your talk. It was really interesting to hear. So now I'd like to introduce our last speaker of this first session this morning. So our next speaker is Simon Turner, and he's Senior Technician in the Department of Chemistry at Imperial College London. And Simon will be presenting a talk today titled Realising Ideas in 3D. So they should be there.
No.
So yeah. Are those your slides?
No.
No. Yeah, so Simon Turner, everyone. Thank you very much.
Good morning, everyone. Yes, my name is Simon Turner. I've worked in the chemistry department here at Imperial College for the last 38 years. I was initially employed basically as a lab monkey, just looking after the chemistry lab. But I work in physical chemistry, and physical chemistry involves a lot of instrumentation. And it quickly became apparent that we could do a lot more in repairing and actually making instrumentation if we had the tools to do it. So over a number of years, I developed a workshop, and this is it. Slightly untidy and messy workshop, but mine nonetheless. And as you can see, it's not a professional workshop. It's basically hobbyist machines. So I'm not going to be sending rockets to the moon from this workshop. This is just things for doing technician stuff, repairing stuff, making small pieces of equipment. So once we got this going, it suddenly dawned on the researchers that they might need small bits of work done. And they started coming to my door, can you make this, can you do that? And so this morning I'm going to give you a couple of examples of that and how I approached making these things and what my thoughts about them were. So the first one was an academic came to me quite recently, and he asked me if we had a particular make of spectrometer in the lab. And I said, no, we don't. We have many spectrometers, but not that particular make. Oh, right, okay, he said. So I started talking to him. I said, well, why are you interested in such things? And in actual fact, what he was interested in was one of those. Now, this is, it looks quite complicated. It's not. In fact, it's a sample holder that screws into a particular make of spectrometer. And he said, we've got this. It's very useful for our research. He said, but we've borrowed it and we've got to give it back. And he said, you haven't got anything like that? I said, well, I haven't, no, but I could make one. And he said, could you? I said, yeah. Because looking at that, I don't know if he thought it was a particularly complicated piece of thing, but from my point of view, all that is a few pieces of machined aluminium screwed together and a couple of steel bars. So we sat down and I said, it's got a lot of functionality there. Does it need all that? He said, no, not at all. He said, it just needs to be bolted down to the spectrometer, which is what the large thumb screw on the right does. It needs to have the capability of the sample holder to slide back and forward on the metal bars, presumably so you can focus the sample. I'm not actually sure whether that's true or not, but and then the major piece of functionality is the square hole in the middle of the sample holder, which is where the beam's going to go through, and that has to be in the right sort of place. So we discussed this, and we decided that the 3 screws for levelling were not actually needed. A lot of the clamps and things on the actual sample plate weren't required because that's what the blue tack's for. So I measured it up, took on board his what he did and didn't need, and made one. Now this is as it is come hot out of the oven, so to speak. And it has all the functionality that he required. The hole in the middle is was carefully measured and made sure it was exactly in the right place. The thumb screw is in the right place to screw it down. And you can just see peeking around at the back there's another thumb screw which holds the clamp for when you slide it along the metal bars so that you can hold it exactly in the right position. So comparing the two, the one on the right is the one that the company make. The one on the left is the one I make. This was, it's quite interesting. It isn't, the one I made isn't black. And I can't remember if subsequently we painted it black. I think we must have done. But this is what I call the condition it was in when it went for a fitting. Because obviously you make something, you hope you've measured it right, you hope you've got everything in the right position, but it has to go back to the person who wants it so that they can fit it in their machine and make sure it's going to do exactly what you want before you go to all the bother of painting it, in case you need to change it. So I can't remember now whether it needed changing or what, but that was the result. Now, the other thing to mention about this is that if you go to the company and buy one of their products, that will cost you something like £800 plus VAT. The one I made cost naught plus VAT. All of the materials we had on hand, quite a lot of it was actually recycled from pieces of equipment that were no longer of any use. So I'd broken up for the useful bits, the thumb screws, various bits of the aluminium. So that for researchers is quite helpful. If they don't have to spend getting on for £1,000 on a piece of kit that they may only use for a limited number of experiments, this is, in my view, a very useful thing to do. So that was a fairly straightforward piece of work. I had the original, I just had to measure it up and reproduce it. More normally, I'm presented with this sort of thing. Chinese postdoctoral researcher called Leng. Well, I knew him as Leng. I think he had a longer name, but I knew him as Leng. And he came along to me with this drawing, or sketch, I should say. It's not a drawing. The fact that it's not a technical drawing is not really a problem. Majority of the stuff I have done, I'm not actually an engineer. I'm a chemistry technician. The majority of the stuff I have done has been what we call fag packet, back of a fag packet drawings. So I had a look at this, and it's a 16 centimetre disc, which is a bit of a pain to make. So I said, does it actually need to be a disc? Can it be square? As you can see, I've put a dotted outline around it. And I think eventually we decided that although all the elements on it need to be radially distributed, the actual thing itself can perfectly easily be a square. So that was a fairly obvious bit. 8 centimetre hole in the middle, not a problem. Things at the cardinal points are diodes, I think, and they were fairly straightforward. And then there was all the strangely shaped sort of trapezium things set out around the edge. And I said to him, so what exactly are those? Now, what it turned out to be, it transpired, were these. This is a diode ring I made subsequently for a teaching experiment. We do similar things, rather less complicated. And as you can see, that the diodes there are set on little metal wedges, and the purpose of that is to focus all the light to a point where your sample will be. Now, you can see there those wedges. They're slightly complicated to make. They're not the easiest thing in the world. And the problem for Leng was that English was not his first language. His English was rather better than my Chinese, but he was quite difficult to understand. And it took me a while to work out what it was he was trying to get me to make. And he wanted 16 of these, so I had to get it right, really. But then I realised that for Leng, possibly my London accent was not quite as comprehensible as the English that he had learnt from. And also, I have a tendency to colour my language with what the French call phrase idiomatique. So I say things like, oh, blimey, you want jam on it, you do? Now, an English speaker would realise that was a phrase idiomatique. They might not know what it meant. But for Leng, that would be difficult. He'd possibly recognise it as not straightforward language, but he might think it's an engineering term. You put jam on it, that makes it work better. So I had to be very careful to not only understand what he was telling me, but to make sure that what I understood from him was exactly what he wanted. To say back to him, so let me understand this. These wedges have got to be like this. They've got to have fixing points on the bottom. They've got to have fixing points on the top at a particular angle so that the LED fits onto it. Yes, and you want 16. So that's what I did. I haven't got a picture of it. It was an awfully long time ago. I produced this thing. And I think we got there in the end. But it was quite a difficult project. And as I say, the language barrier made it that much more difficult. And just as I'd finished that one, somebody else said, that's brilliant, can you make me one? And so that's all I have to say today about my ideas, about if somebody comes along with an idea, how to make that thing and to make sure that it's what they want. Thank you.
Thank you very much. It was nice to see a workshop. I think there are many of us who'd like to have our own little workshop of ourselves.
Yes, yes, if I had a garage.
Yeah, exactly. Do we have any questions for Simon? Yes, thank you.
Hi, Simon. I hope my English is good enough so that
sure
there's no problem with communication. So very interesting talk, and I kind of had several ideas about what your talk draws to a bigger problem with the cultural heritage industry. One is, when funding is limited, can we hack something to just make it work? I think that speaks with a lot of us. Like when we have limited resources, how can we make the best use of our knowledge and materials to make things right? And that kind of connects to the last speaker's marble ID. It seems like these two objectives are conflicting, while the producers are trying to protect their IP, and then researchers with limited resources had to hack them in order to make things work. What's your thought on that?
Yeah, materials is a bit of a vexed problem. It used to be the case that instrumentation was made out of a lot of useful material. More recently, things have got cheaper and cheaper. Plastic is now used, mouldings particularly, where it used to be big chunks of brass, big chunks of aluminium. So there's less opportunity to recycle stuff, I think, than there was. And your other point was?
It's like, how do you resolve that tension?
Sorry, how?
Because there's a tension between companies who produce these high-tech research equipment versus smaller research groups that doesn't have the fund and have to ask for people like you, the experienced technicians, to hack something to make things work. And do you think there's a better way of doing that rather than just, take the measurement and or a better way of communication, open source, things like that?
I don't know. The thing is, scientific companies are always in this problem that they make very expensive machines and they sell one to you at high cost. And then in 20 years, it will be too old and you'll buy another one. But for those 20 years, they've got to have a cash flow. And that's why you find that you buy a nice bit of kit and it has sample pans or something like that, and you find that the sample pans are extraordinarily expensive. And that's because the company's got to do that. Now, interesting, certain irony about the previous speakers who were talking about trying to stop people copying things. I know I've just said, oh yeah, well, we copied that, that was no problem at all. I don't think those sorts of things are patentable, so I don't think there's a problem with that. I don't know how you get around it. A lot of what I have done has been not so much producing things. It's been adding on to, somebody's got a microscope and they want something added onto the stage to do a particular thing. So that's a more of a different thing. And I don't know. If I can do it, I'll do it. But I don't really think about the philosophy behind it, I must admit.
Okay. Well, thank you very much for the questions, and thank you again, Simon. So I'd just like to thank all our speakers once again from this morning's session. So we're now going to have a very short break. The session's going to resume back in here at 12 o'clock. So outside, back on the concourse, there'll be some tea and coffee, some light refreshments, and you can also use it as a comfort break. Whilst this break is going on, during the break in this lecture theatre, we'll be playing a video about the Royal College of Science plaque stonemasonry restoration. So this video will be shown during each break, and we'll just have it on loop. So this break, the lunch break, and these subsequent breaks as well. So that'll be played on here. So thank you all again, and I hope you enjoy the rest of your day.